Good morning. My name is Ian Watson, and I am the Executive Director of the American Membrane Technology Association, otherwise known as AMTA. Our intent with this series of Pioneer Chats is to record the history of the development of membrane technology within the United States. In doing so, we have been interviewing several members that took part in the early days. We intend to archive these chats with the pioneers, as we call them, and make them available to our membership so they can look and listen to some of the people who were instrumental in moving membrane technology forward to where it is today. This session of our Pioneer Chats program, we have two pioneers. On my right is Mr. Dave Stahlhut, who spent, I think, most of his career with the DuPont company.
Yeah, most of the DuPont career.
That's good. And on his right is somebody I've known for a few years, Mr. Sherman, who has a long and varied, and I'm sure a very interesting career in desalination at various locations.
Yes.
If you would, Dave, could you give us a little bit about your background, education, how you got to DuPont, and how
Sure.
you got into the Permaset business?
Getting into the Permaset business is sort of an accident, like all my other DuPont jobs, but nevertheless, it was an important one for me. I was a chemical engineer from Iowa State University. Went to work with DuPont in West Virginia right out of college, and worked in their manufacturing and their manufacturing technical organization in a couple different sites, until I showed up in Delaware and got an opportunity to join the Permaset organization. And that was about 1978, I believe. And I started out, first job with Permaset was as a technical supervisor for the manufacturing technical and development groups for the Glasgow site, where we manufactured the devices, and also for the Waynesboro, Virginia site, where we manufactured the hollow fiber membrane. I did that for I think about 2.5 years, and then moved to another business in DuPont, Vespel. We manufactured high performance parts there, but totally unrelated to the desalination business. And then when DuPont entered the spiral business by purchasing Ajax in 1982, Permaset asked me to come back, and I was the manager of the spiral manufacturing facilities in San Diego. That lasted about 10 years. During that time in DuPont, it was an era where we were trying to accumulate spiral cartridge manufacturing technology so that we could take our membrane experience, see what kind of flat membranes we could make, and see if we could make a competitive brackish flat membrane in a spiral configuration. So by buying Ajax, we immediately acquired the spiral manufacturing technology, and then the San Diego plant was the site where we would take membranes, flat membranes, which we produce either in one of 3 locations, and turn them into spiral cartridges and see how they performed. During that time, we did have a little bit of cellulose acetate business, kind of left over from the Ajax business, and a few sales that we made, but it really was quite small. We did that for about 10 years, and then exited from the flat membrane business. And we can talk more about the reasons for that later, but we left the flat membrane business, decided to focus on hollow fiber seawater business, And I relocated back to Delaware and became the manufacturing manager for all of Permacep's manufacturing operations in the leftover in San Diego and at Glasgow and at Waynesboro. I did that for about 3 years, I think. And then I actually was thought I would retire from DuPont and from my career, and I did. And then immediately went back to work as a consultant for the Permacep business, full-time first, working with Samir DeBas and later Fareed Salam and the marketing organizations. Working primarily on the large seawater projects that we were pursuing at that time, because I had experience across the board in R&D and manufacturing and spiral and hollow fiber. I ended up as kind of the intermediary between all of our large contractors that we partnered with in these projects, between the manufacturing organization, the development organization, where we were producing the products that were going into these projects. And I did that on a decreasing basis as the Permacep organization worked their way towards phasing out of the desalination business, and I retired from the desalination business then full time about the year 2000, about the same time DuPont was exiting the business.
Good. Sherman, what about you?
I got a degree in mechanical engineering from UC Berkeley and a master's from SC. And my heart's desire was to go into the aerospace industry, and I went to work for making the rocket engines that got the man to the moon. So I worked on the J2 engines and did that for 7 years, and employment had peaked somewhere over 20,000 and was down to 3,500, and the slope was further downward. I figured I'd do something else, and I sent out resumes, and I went to work for a company, Baldwin, Lima, Hamilton. And I'd sort of like to talk about Baldwin, Lima, Hamilton, what it led to in other companies, and the close association it had with DuPont, and some of the people who worked at Baldwin and what their careers were in desalting as well. Baldwin was famous for making steam locomotives, but that business went away after World War II, and they were a very large manufacturer of large equipment, very large equipment. In fact, some of the pumps they make are 80,000 horsepower each. But they had a heat transfer division which was involved with desalting. And the desalting experience went back to the turn of the century. They were making 2 effective evaporators to make purified water for boiler feed, that type thing. And they were very good at making distillation equipment. So good that they had overseas licensees, Franco Tosi in Italy and Sasakura in Japan. So one of the example projects they had was in Eilat, Israel, in about '62, was in a 1 MGD MSF plant. But anyway, they had foreign licensees. And about this time, I went to work for BLH in 1970. About this time, I think DuPont was figuring out what's the best way to start selling their systems. And they decided to have BLH, because of its foreign licensees, partners to market overseas, and they selected Permuted for the U.S. manufacturers and suppliers. So I worked with DuPont closely for the next 2 years. I helped start up their first commercial plant. It was in Greenfield, Iowa, probably about '71, I think.
Yep, that's right.
And then what happened to BLH is we were acquired by a much bigger company, and they decided they weren't interested in manufacturing. Sold off all the manufacturing, company went down to zero. sold off the desalting part, which I was part of, to Envirogenics. BLH was in Pennsylvania, which was very convenient because we were quite close to Glasgow, where DuPont was marketed. But Envirogenics was in Los Angeles, so moved back to Los Angeles and worked for Envirogenics. Envirogenics was very much into developing membranes both for brackish water and seawater systems. We could probably talk about some of the projects later, but
Right.
point is they were very good at developing spiral wound membranes using cellulose acetate. And I worked for them for 2 years, from 72 till 74. Meantime, when BLH went out of business in 72, one of the key guys was Al Rogers, and Al went to Bechtel at that time, and Bechtel was located in San Francisco. Another person, old timer from desalting, is Leon Arbach, and he got his first job at BLH when he came to the United States. He came directly from Poland, and this was in 72. He went to work for BLH, worked there for a while, went to Aquachem, but in 74, Al Rogers asked Leon to come to work for Bechtel, so he went to work for Bechtel. So now there was Al and Leon, and Leon invited me into Bechtel, so I started, and then Leon hired another gentleman, Victor Vandermast, and Victor was a PhD candidate out of Berkeley. And so that's my introduction into desalting. We stayed together at Bechtel. I worked for them for 25 years. Officially retired when they spun our division off to something else. And that was like the year 2000. Since that time, I worked for other engineering companies and myself as a consultant. So I still do some desalting work.
Good. Now, did you get involved in thermal work at all, or has it been mostly membranes?
I did some thermal work too, especially, well, both at, mostly at BLH, because we were developing some vertical tube evaporator type things. Part of the business they sold in Envirogenics was their distillation experience, and Envirogenics was very good in distillation equipment, especially vertical tube evaporators.
Now, Dave, what DuPont decided, let me rephrase that. When DuPont developed the B9, or the early permeators, at that time, the competition, which was primarily Fluid or Roga in those days,
Correct.
Was selling systems. DuPont elected not to do that. Did you know why they decided not to do that?
Well, we had that discussion probably twice a year at our business meetings, and it was always an active discussion of whether we should go into systems, whether we should become a utility and sell water.
Right.
I guess all I can say is that it's a healthy discussion, and in the end, the arguments that won were the arguments that said we had best market access with the approach that we took towards developing a network of licensees, and that our strength, what DuPont brought to the table, was the technology around the membrane itself.
Right.
And so I think it was early on, at least, a case of where we thought we would best serve the company DuPont and serve our own business and serve the market, really, if we stuck to that part of it that we believed we could do very well.
Right.
And
Right.
so, but it was discussed all of the time, of the time.
And so Bermuda was your first domestic licensee?
Yeah, that was before my time with the company. We had over the years of my experience in the manufacturing end, we saw many many licensees.
Right.
But yeah, certainly they were a big important one for us.
I think
early on.
DuPont also licensed Water Services of America.
Yes.
Yeah, later on. It was Gordon Leitner.
Yep.
When you were, did BLH become the overseas licensee while you were still?
Yes,
Yeah.
because we were just, I think DuPont was very early in the development in 1970 when I went there. And I helped develop the overseas market. I went to the Canary Islands with a pilot plant supplied by DuPont and worked with our Franco Tosi licensees. Didn't work as much with Sasakura, but I do remember one of the early episodes. I helped start up their DuPont's first commercial plant, like I said, in Greenfield, Iowa. And there was a guy, Vic Tomsic, I think was his name, and we thought we'd turn the water on and see what happens, and well, found out somebody had forgot to glue a PVC joint together, and we pretty much flooded the place at that time.
It was your baptism.
Yes, that's right.
Still happens, by the way.
Yeah. And I think we were also involved after I went to work for Bechtel with probably the last job that DuPont bid on. We were bidding on Fukuoka, which is a plant in Japan, and Bechtel was associated with Taisei, which is a Japanese construction company. We were joint bidding on that project. Kept trying, this was end of '99, and we were developing the bids, and kept trying to get an official bid out of DuPont and couldn't quite get it. And after we turned the bid in, we found out that DuPont had decided to go out of the business, which made it pretty difficult to sell that job, but we tried. Another interesting aspect of that was there had been a lot of talk about trying to get American engineering firms to work with Japanese, and so that's what Bechtel had done. Well, when it came to the Japanese doing the bid evaluation, they decided what they do is have the final oral presentations at Christmas time. It's not an official holiday in Japan, but it is here, and so it made it a little difficult, but we managed to still put together the presentation. Unfortunately, as I said, we didn't win, but for obvious reasons.
When DuPont decided to bow out of the business, did they make any effort to sell the Permaset group as a group to somebody else?
That was, I'm sure it was looked at. There were issues I know that they would have to overcome to do that. I was not involved at that level of the organization at that time, but some of the issues with DuPont in divesting or selling that business is there were a lot of other ties into other parts of the DuPont business that made it a complicated process. It wasn't a standalone unit, particularly in the manufacturing of the membrane and of the polymer that went into the membrane. There were practical links related to the location and the chemical processes used to develop that, as well as some issues around the technology itself that made it difficult to sell part of that technology without risking technology or access to that technology in other areas as well. So it would have been a difficult task.
Right. But DuPont did support the product for a couple of years.
Yes.
After you quit making it.
Yeah. Well, we had quite a few commitments that we had to live up to, right. and work our way through. And I'm sure that was a challenging part of the decision.
Yeah, I think I saw a statistic one time that DuPont had something like 75% of the seawater RO business.
That might be an overall total, early on it was even higher than that.
Yeah.
That was our strength, and I think I'm sure it played into the final decision when that market dominance was being attacked.
Right.
And that was what we viewed certainly through the 90s and
Right.
even into the 80s as the strength of our business.
Yeah, one thing that some of my associates that worked there told me that it was very difficult technically to modify the fiber to give it the same kind of performance that was currently coming out of the flat sheet market. It was, it was kind of, it was what it was, and it was difficult to do the surface modifications necessary to improve flux and salt rejection.
Well, just think about the differences in the construction of the device, and if you think about the transport that has to occur across not only the membrane, but then the transport of the product water down the bore of the fiber,
Right.
Creates a whole set of constraints which have to be optimized to give you the right fiber diameter inside and then outside diameter based on the strengths and the pressures that you're running at, and we of course have huge amount of surface area packed into a cartridge because of the fine fiber, so that creates issues on the feed and reject side to make sure that you have the right kind of distribution. So it's technically, it's amazing to me that such different technologies could be so common at the front end,
Right.
in concept based on a membrane selectively separating ions from water, and at the finished product end, we all get drinking water out of the device.
Right.
But in the middle, it sure is a big difference on
Quite
how we
different.
went,
Yeah.
went about doing it.
Yeah.
And to have those two technologies being developed at roughly the same period of time, to me is pretty amazing.
Sherman, you mentioned while you were at BLH, you did some work in Canary Islands.
Yes.
Was it? Was there anything else that happened with BLH and either directly or with some of their foreign licensees?
Mainly it was, we were just starting into the development of and marketing of the DuPont membrane, so we didn't have too many other major projects in that period of time. In fact, it was like about a year and a half that I worked there. When part of the rationale for getting out of the aerospace industry, I wanted to go to work for somebody who would be around in the future, and BLH had been in business over 120 years. And my wife called me at work one day and says, BLH to close its doors is what the headline said. And so really only had about a year and a half worth of time to try to get much done in desalting.
Yes, I remember rightly. It wasn't much after that Sasakura bid a big project in Bahrain with the DuPont permeators.
Yeah. Part of the distillation business was continued with Sasakura. They built a 50 million gallon a day plant in Hong Kong.
Which never operated, I don't
That's
think.
correct.
That was on the top 10 list of worst projects.
That's right.
Tom Pancratz did a couple of days ago. Yeah, I remember that Hong Kong project.
Yeah.
Yeah, never operated. So you went to Envirogenics, having kind of cut your teeth on hollow fiber membranes. Now you're looking at flat sheet. And what was your reaction when you got there and saw this strange-looking device?
I didn't go to the office at first. I think there was some turmoil that had gone on at Envirogenics, so My first coming back from East Coast, I went to Roswell, and they had Roswell was an OSW test facility on brackish water, and we had or Envirogenics had a high recovery RO system running there. It's designed for 95% recovery, and so that was how I cut my teeth on membranes at that point. And but Envirogenics is trying a couple different. Well, this was early on in seawater desalting, and they were trying different techniques to come up with a membrane. They had tubular units. We had OSW also had its facility here in San Diego down at the South Bay Power Plant, and we had called the Big Blue Box. It had something like 1,240 tubes in it, which had membranes on the inside of the tubes. There was a stainless steel tube in the outside, and we were just doing development of that process. Concurrently, we were also testing out spiral wound membranes, but membranes weren't good enough in those days to do single pass, so we were developing two-pass RO systems. So it didn't take me too long to get familiar with spiral wounds at that point. Yeah. Certainly I found them a lot better than the hollow fiber, not hollow fiber, excuse me, than the tubular units. The tubular units had none of the advantage of
it's not enough surface area.
That's right. I mean, it took a huge box, third of the size of this room just to get a few thousand gallons a day type thing.
Yeah. The now, were you at Envirogenics when they bid Hackle and Duba?
No, that was after me.
That was after you had left.
Yeah.
Because that was, I think that was they were both two-pass systems, as I recall.
When I was there, we bid also on for Riyadh a brackish water plant. We didn't get that, but that was interesting design. They had a lot of hydrogen sulfide in their groundwater, and it was pretty high salinity as well.
Didn't Ames cross the Babcock wind up getting it?
Could be. I can't remember who got it. Just when we lose, I want to forget the project fast.
Yeah. So, Dave, after you had been in Glasgow for a while, DuPont acquired Permacept, but I guess it was DuPont, acquired Ajax, and sent you out to the West Coast.
Yes, that's correct.
And what was your impressions when you got here?
I guess I was surprised when I walked in the door how small of an operation we had purchased. But they were really, it was an excellent crew. It was, of course, who could not love San Diego when you're moving from the East Coast? So I was enjoying myself. It was a wonderful experience. That whole era was exciting for us because we were bringing some new technology to DuPont. It was kind of like the second phase of intense research activity in DuPont. The first phase really was very early in the game, in the I'd say 1960s and 1970s when the initial developments were made, and then once our B9 and B10 devices were commercialized and we were selling systems, the development shifted to more of a manufacturing technology development process where we were trying to reduce variabilities and achieve incremental improvements in the product. And this went on until we purchased Ajax, and that was a significant second effort in development for DuPont, because we were not only working with new device technology, but we were also spending quite a few of our resources in our experimental station, we called it, our big research facility in Wilmington, Delaware, trying to develop flat membranes. And we didn't want just another thin film composite membrane to join the crowd. We wanted something that was unique and would offer some sort of competitive advantage if we were to make a recovery in the brackish market at that time. And so we had two thrusts. One was to see if the membranes that we were using in the hollow fiber devices could be cast in a flat sheet membrane, and if we could gain the advantages of both the very stable polymer that we had and the membrane that we had with the advantages or the perceived advantages of a spiral device. And then the second approach was to get very basic on our chemistry and try to see if we could develop our own composite type membrane, which would hopefully give us a competitive opportunity. The B15 membrane was not anything exciting. We didn't perceive that it was going to give us an edge, and so we kind of switched horses, and the best strides we made were with the composite membrane.
But there were a couple of systems built with B15s.
Yeah, yes, yeah, and as well as the CA membranes that we produce.
Right.
Yes,
Right.
yeah. And I couldn't tell you who. That's now 25 years ago, I guess. So for someone who's been out of the business for 10 years, I've forgotten a lot more recent stuff than that.
In your time at Envirogenics, Sherman, what is there one particular project that stands out as being memorable for either because of its success or maybe its failure?
Oh, I think the most fun and the things I remember are our pilot plants down for the old Office of Saline Water in San Diego. Variety of unknowns that we had to solve at that time, and all the technology that had to be discovered. In those days, they didn't use fiberglass elements. They used placite coated carbon steel. All you had to do was nick that a little bit, and almost invariably there was acid feed, so the acid would start attacking the steel, and then that would mess up the membrane. So,
yeah.
And in fact, the big unit I talked about that with the tubular unit, we had positive displacement pumps on that, and we started getting iron fouling in that. And we bought everything stainless steel in that, including the big positive displacement pump. I mean, this is like 100 horsepower or so. So I started going around with a magnet one day, and I found out one of the blind flanges they had on one side, they put in carbon steel and painted it over. And, and it looked like a dish when we took that thing off because of all the acid had eaten away the steel.
Yeah, we've actually, it's funny you should mention that because we've had kind of an interesting history with stainless steel. So, the standard in Florida was always 316L. And so a couple of plants were built, and within 6 or 8 months, pinholes started developing in the pipe, and we found out it wasn't 316L, it was 304L. And somebody had written 316L on the shipping notice. And then we started getting stainless that was rolled and welded pipe rather than seamless from Korea. And they claimed it to be 316 stainless steel. And you ask them for the materials certification, and it's missing about 3 of the components that actually make up 316 stainless steel. So I know what you mean. I've been there.
I discovered one thing. I mean, if you had really small leaks with seawater, it could sometimes close off because the salt had come through very slowly.
Plug it up.
Plug it up.
Yeah.
Which was hard to believe in 1,000 psi systems, but it worked.
Now, were you there when Virogenics did Lake Killarney?
Yes, I
Yeah.
was on that one.
Yeah.
That was interesting because, yeah, I was in charge of that, but I didn't complete it. That's when I left. And that's when we were going through inflation, and all the manufacturers were up to their eyeballs as far as supplying equipment. One of the big problems on that was the high pressure pump, and all of a sudden we can't deliver it when we said because some bearing is not available. And it became a supply issue on getting that thing built is what it amounted to. We'd sent somebody down there to do some pilot testing to make sure we got the appropriate pre-treatment system for that. And anyway, unfortunately I left before that one got completed.
So with the flat sheet was actually made in Delaware, and you rolled the elements in San Diego.
We actually had 3 different locations where the flat sheet could have come from during the course of that development. We had a film plant in Towanda, PA, I believe, or New York, where we manufactured some of the B-15 membrane. We had we could manufacture flat membrane at the experimental station in Wilmington, Delaware, which is a large research facility for many of DuPont's product lines, not just Permaset. And then towards the end, we had a machine at Glasgow, Delaware, where we could make the composite membrane.
Right.
Yeah.
Did you
And we
have
made cellulose acetate membrane in San Diego.
in San Diego,
Yeah.
the old Ajax
Right,
facility? Right. Now, eventually, based on decisions that were probably made above your head somewhere,
Probably, yes.
it was decided to get out of the flat sheet business, and you sold that part of Permaceps to Jim Bartlett at
Correct, yeah.
at Tricep,
Tricep.
right? Yeah. Now, did he also buy the ability to make the membrane material itself, or did he have to develop his new membrane material?
No, they got all of the equipment and
And they got all the
everything,
equipment and
yeah.
everything.
Yeah.
Okay. So, Sherman, when you got to Bechtel, reunited with our good friend Leon Auerbach
Uh-huh.
and Al Rogers, what sort of things were you doing there at that time?
We were doing mostly foreign type work. The other job was convincing other parts of Bechtel that the salting was real. But anyway, we had several projects in Saudi Arabia. Victor Vandermast had a 15 MGD plant that went in Jeddah. And boy, he lived and breathed to get that job done. And then we got another job, and I was in charge of that, Medina Yanbu. We did a design on that and then specifications for that. And it involved a power plant, MSF plant, and also a RO, seawater RO plant. And putting together the specs on that was a real challenge because we had 3 different vendors that were going to be at the site, and trying to get it integrated so that somebody'd build the intake at the appropriate time so it didn't mess up the RO intake at a later time. And I think one of the big contributions I made on that and putting the spec together was make a separate spec that was called the interface spec. It tried to identify who was responsible for which and what in that thing, because it was going to be very complicated.
Yeah.
It wasn't all going to be built at the same time. But that was one of the bigger jobs. But Bechtel
And that was one of the first so-called hybrid plants, wasn't it?
That's correct. Yeah.
Yeah.
Leon was a big advocate of the hybrid process, and we did that. Actually, I ought to go back to the Jeddah plant. The reason the Jeddah plant went there, they'd put a distillation plant in before that, and it was an acid feed plant. And as we have discussed about the effects of acid on steel, that's what happened to the MSF plant at Jeddah. So they replaced it with RO, and they've been very successful with that plant. Saudi put in a duplicate to that plant later on. So
And that's Toyoba membranes.
that's correct.
Toyoba hollow fiber membranes.
Hollow fiber and cellulose acetate.
And cellulose acetate.
Yeah.
Yeah. Interesting.
Yes, there's a lot of discussion on which membrane type is appropriate, but Envirogenics and Toyoba both, and DuPont Fluid Systems started out with cellulose acetate as well.
As did Hydronautics.
Ah, okay.
The only one that didn't, I think, was Filmtech, who bypassed CA,
Yes.
went directly to thin film composite.
Had that patent,
Yeah.
so-called patent protection.
Yeah. Right.
We did other work at Bechtel. One of the things we did was geothermal desalting test facility here in the Imperial Valley. That was probably
That was a
around.
pretty interesting project.
It really was. The concept was there's a lot of geothermal brine, and maybe one thing to do would use the heat from the brine to desalt the water. And one of the big issues here in California is what to do with the salton sea, because it's shrinking with time. And the idea would be get the purified water and put that in the salton sea. So ultimately what's gone into that location is power plants since we left. But we had a MSF plant at that site, also a vertical tube evaporator. We also worked with a high temperature electrodialysis unit there too. Anyway, all three of those. And we had pre-treatment systems. Anyway, that was really technically a challenging job. One of our things was between Leon, myself, Al, and Victor, we were exploring different avenues to keep ourselves busy, and we worked with EPRI on scaling from geothermal fluids on turbines. So we had a pilot plant in the Imperial Valley where we were, silica scale is a real issue for geothermal systems. One of the things that's really interesting about desalting is the technology can be applicable, that you develop as far as the chemistry goes, can be applicable in other areas, including geothermal power production. So that's one thing we looked at. And like I said, you know, really one of the starts in scale control was some of the stuff that BLH had done on MSF units. So we had that as a background, and DuPont did a lot of work on DuPont probably had one of the best publications available for designing RO systems.
Oh, absolutely.
Yeah.
Yeah, absolutely.
And anybody can get a copy of that these days is lucky.
Widely distributed.
Yeah, it's widely distributed. And
I still have my original edition, and I also have the
That's probably a
updated one.
collector's item.
That is, and I'm hanging on to it.
darn right.
Yeah, to get back to the flat sheet side of DuPont, as you said, when you got there, it was a relatively small operation,
Yep.
just a few people, and it was all cellulose acetate. I remember an A15 membrane.
That was the final membrane that we produced. It was a composite membrane,
Right.
different chemistry, and that's the. If we had been able to go forward, it would have been based on that membrane or its successors.
Do you remember the characteristics of that membrane?
No.
Shucks.
No, I really wasn't involved in the development at that time, because the development was taking place at the experimental station for the membrane. We looked at many different formulations before they settled on the A15. Our issue with the A15 was figuring out how to put it in a device in a way that the device would perform for a long period of time. The whole last phase of that development went fairly rapidly. From the time that we had the A15 membrane through the period where we were developing the devices to the period where DuPont made the decision to withdraw from that market. And I think there's a variety of reasons, business reasons. After roughly 10 years in the spiral business, the whole focus of that effort was to see whether or not we could could recapture a leading position in the brackish side of the business.
Right.
And we weren't successful. We didn't do that. There was many people in the business who believed that really our strength was the seawater business, seawater membranes, and they saw the big effort that we made in the flat membrane business and the spiral cartridge business as a distraction to what was really our strength.
Right.
And so when we exited the spiral business, that's when I moved back to Delaware, took over the manufacturing for the hollow fiber business, and also the development work that was going on at that time to develop new seawater devices, not new membranes,
like
new
the
seawater
twin
devices. The twin,
Yeah.
exactly.
Yeah.
That was with Tom Ekman at the time,
Right.
who was in my development group. The twin and the a more subtle development was the compact B10, and what we were able to do over a period of time through the incremental changes in our manufacturing process is develop the B10 membrane continued to improve. We got better rejection and better flow through the membranes, so we reached a point where it made sense from a hydraulic standpoint to reduce the length of the cartridge because the bore pressure drop was making a significant part of the cartridge not very productive from
Right.
a RO standpoint. So at the same time that we introduced the twin, we introduced a smaller or a shorter version of the B10, which had, I think, exactly the same flow specification and maybe a little better rejection, if I remember right. And we switched pressure vessel concept at that time and went with the code line pressure vessels. With hollow fiber, a disadvantage we have versus spirals is it's pretty difficult to get more than one cartridge in a pressure vessel.
Yeah.
And in a seawater device, a big part of the cost are the pressure vessel enclosures and the pressure vessel itself. So the twin first was our attempt to try to approach that competitive issue. Later on, it was we also developed cartridge devices where we could put several. I think we could comfortably go to 3, 4 maybe, but really 3 was the ideal.
Now, at the time, the decision was made to get out of the flat sheet business. How many people did you have working in San Diego?
Not many more than we had when we started.
Mm-hmm.
San Diego workforce went up and down depending on the activity that we had. We had a core group of employees who stayed with us, and then if we had a project that we had to sell, we'd hire additional people or bring in temporary labor where we could do that. Right. But as once the decision was made, then of course things tapered off rather dramatically. Yeah. So at the end, it was a very, very small group.
Now, with the A-15, did you? I seem to recall that there was a plant at the Diablo Canyon nuclear power plant. Hydronautics had a plant there. And I think Ionics built a plant and used the A-15.
I thought Permacep had a plant there as well early on, but I may be wrong.
Could be. I don't remember that, but I think Ionics built a plant and used the A-15 membrane.
Okay.
And it was shortly after that, I think, that.
Yeah, I know we had several small projects, and it's been too long ago for this mind to remember the details of that. But yeah, we did have through our licensees, we had places where we actually had the membranes out operating, where we had a chance to get some, I guess, put the tires on the road. But really, commercially, it certainly was never anything compared to the seawater business.
Right.
Yeah.
Right.
But really, that was another basic shift in Permacep's approach towards the business. When we decided that our opportunity was truly in the seawater business, then we focused on some other strategies to try to figure out how we could capitalize on what we viewed as a very stable B10 membrane.
Right.
We recognized that if we were going to be successful, we were going to have to figure out how to, the world was going to have to figure out how to solve the biofouling issue with B10 plants, because our device, our competitive advantage was in single stage, high conversion plants on the most difficult seawater in the world. That's where
Right.
we had an advantage over any other membrane.
Right.
And
Well, you actually did, as I recall, you actually got a patent on the use of chloramines as a primary disinfectant.
That may be. The one I remember that we were working. I remember we were working on chloramines, but we were also working on, I believe, sodium bisulfite as a route.
Mm-hmm.
But of course the key plant was Adur in Bahrain, which was important for us to be able to turn around, and then if we could solve that problem on those waters, we thought we could treat any water
anything.
anywhere
Yeah.
in the world, and we weren't successful in really once and for all solving those issues.
Yeah.
That's for a variety of reasons.
That plant was also
some of them
on the
technical, some of them other.
That plant was also on the list of
Yeah.
10
Yeah.
not so good.
Well, isn't that the plant where some of the early work was done on? I think the way it was designed originally, there was a continuous chlorination of the feed water, I believe. Isn't that the plant where they
chlorination and then dechlorination.
and then dechlorination? Yeah.
I think you might be right.
But I think
I
that
don't
they
know.
also, later on, that was a plant where they started shock chlorination on an intermittent basis and solved, if not all, but certainly some of the biofouling issues, because they turned out. Remember
Yeah.
in the early days of CA seawater plants in Saudi Arabia, they used to chlorinate, and they had this compound X.
Yeah.
Do you remember that?
Yeah.
It turns out that it was actually they were helping the bacteria grow because they were creating assimilable organic carbon, which is bug
These are
food.
diatoms.
Yeah, but they break up and then they turn into bug food. And when they quit doing that and just had intermittent shock chlorination, they were killing the things, but they weren't creating enough food for the ones
Right.
that were hiding to be able to survive. So all the plants operated a lot better.
Right.
Yeah. I remember. I thought that was fascinating. I remember reading about that.
Yes.
And I read a paper by a couple of Indian scientists on a power plant in India that did the same thing with mussels in the intake.
Ah, okay.
I always thought that with the biofouling that things that induced frequent changes in the quality of the water that the biofoulant saw had a better opportunity than those kinds of things that were continuous.
Mhm.
Because if you have a continuous quality of whatever it is in the feed water, there's a higher potential that the organisms that manage to survive in that would take over and become the main issue.
That's right.
And so that by inducing some control system that involved changes, it inhibited the development of a stable species.
It upsets their normal rhythm.
Right.
Yeah. So, how long were you at Bechtel? 25 years, I think you said.
Yes.
So, what other projects did you work on there?
There was
Must have been some.
quite a few, actually. And another project was there's a Saudi industrial park in Saudi Arabia. Dr. Bushnak was our key contact on that. And we were looking for a place to put in a seawater desalting plant because the industrial park had to buy a lot of water from truckers because there just wasn't a continuous supply. And so we were doing a study for him and trying to find the best location to put in a plant. Ultimately, what we ended up doing was Dr. Bushnak was over here for one of the IDA conferences, and I took him to meet Santa Barbara because Santa Barbara was trying to sell their desalting plant.
Right.
And so they bought the desalting plant from Santa Barbara. And what we did was refurbish it before it got shipped over. And basically, we didn't take the pretreatment equipment, the sand filters, that type stuff stayed behind, but a lot of the equipment had been delivered in trailers, and that included the membrane units, the power plants, and some of the energy recovery things. So, picked up the trailers, put them on a truck, and shipped them off to Saudi Arabia. And I'd seen an article in the Desalting newsletter fairly recently that plant is still operating.
Still operating, yeah.
And that's at least 12 years ago that we made that transition.
Right.
So, yeah, a lot of projects that...
Now, did you get involved in... were you involved in the big Saudi distillers?
Some. When I spent spent quite a bit of time over there. We had one job that we did was a power water master plan for Abu Dhabi, and some of the design work we were doing out of in Abu Dhabi. But that was an interesting job too. The power water master plan is figuring out what part of the job was what's the demand, how are you going to get the power distributed. From the desalting perspective, it was looking at what processes to use, because they were almost exclusively at that time in the big plants MSF units, and developed a computer program, put in cost information, that type thing for the different processes, and RO proved to be a very valuable addition to their overall desalting program. So that was instrumental in getting RO into the Abu Dhabi power water system.
They were very reluctant to go after RO.
Absolutely. They had some very serious problems. They were segregated into large plants and small plants, and some of the small plants were like 1 million gallons a day and less, and they had some serious problems. Some of them were related to intake systems. They had them in very shallow locations and relating to your issues about biofouling. And it was very warm in those waters in the shallow systems. And so I went to one plant and there were parts scattered all over the place because it wasn't operating at all, and they were trying to get it going again. So, but yeah, we also did distillation plant design in Abu Dhabi and some in Saudi Arabia as well.
Yeah, I just wondered, one of the, in my role as a consultant over the years, one of the, when DuPont was competing with the likes of Fluid Systems and Hydronautics for a project with an OEM, one of the arguments that was always made by the spiral guys is that, once you've plugged a permeator, you can never clean it. And look at this spirals, open channels, and, easy to clean. I didn't quite always believe that, but on the surface, at least, it made an argument. Was it difficult to clean the permeators?
Well, I think certainly you'd have to say that with a hollow fiber device, there's more potential for catastrophic type plugging, just because of the spaces involved, but also because of the very high conversions that we would like to run at to have a single pass system. So we spent, our applied engineering group, the group that Irv Mock ran for a time, and was probably one of our strengths of our business. We spent an awful lot of time with our licensees in trying to address those issues. I think Spiral people were probably just as successful as we were in figuring out how to foul up permeators,
Yeah, I've seen a few fouled spirals.
But we had, I would say, very good experience overall. If you think about the technology involved in designing systems that actually can perform with low risk to the operator. I really look back at those times and think that the industry as a whole was pretty successful in doing that. And we hear about it and we think about the failures, and there are reasons. If you operate a permeator at 100% conversion, it doesn't work.
Business was so competitive, and in a way still is competitive, but it was so competitive in those days because it was a big market in the Middle East, and everybody wanted a part of it.
Sure, and
you always heard about somebody else's problems.
Sure, and our big thing in the seawater business is we could do in a single pass what spiral membranes couldn't do. Right. And in an era before the well-developed energy recovery systems, that was a clear-cut advantage, which explains why we had the seawater market, or why DuPont had the seawater market. And then, as time went on, and as the energy recovery systems got better, as the clients got more willing to try putting reverse osmosis in difficult situations, the playing field got a lot more level.
Sherman, is there one particular story you'd like to tell us before we close?
Well, maybe not a story, but I think one of the things that really hurt DuPont was the humid desalting plant. Remember at Envirogenics we had some pilot plants down there, and DuPont had done a great job down there as well, and I don't know if you remember much.
I recall, there's not much I remember from the 1970s, but I think that had to be in the late 70s when that project was awarded.
Right.
I kind of remember that at that time we were also dominant, I believe, we had most of the brackish water business. And our expectation, I was in the manufacturing at the time, not marketing, but the expectation that I recall is we didn't know whether we were going to get 100% of the project or maybe only 75%. That's right. And so it was a shock to the business, and probably the beginning of the gradual erosion of our position in brackish water.
Yeah, but it was, it certainly put hydronautics on the map.
Yeah.
And because we bid a Sanibel project shortly after that, and they came in and walked away with it. And we had a Permutit was there with permeators, and Polymetrics was there with a Dow permeator. Envirogenics bid that job, and it was amazing. Our board of directors looked at that and said, "My gosh, they got 20 million gallons a day." It's like, "Oh yeah, we have to have them." It wasn't until later they found out that Jim Bartlett owned the whole company and flew airplanes. That made them really nervous.
That was a significant.
That was, yeah. Well, listen, I want to thank you both for coming. It's been a really interesting discussion, and learned a lot that I didn't know. I hope you enjoyed it as much as I did, and thank you very much.
Well,